We're in an old gravel pit, and quarrying the gravel, they go down as far as you get good gravel. So a lot of the surface here is the surface left when they got past all the good gravel. But what it does stratigraphically is we have a layer of the poor quality gravels sitting on top of what we call the Kellaways rock. The Kellaways is a middle Jurassic formation. It's about 165 million years old, and it forms, if you like, the bedrock to the rest of the site here. What's really interesting is the quarry, the Kellaways rock is highly faulted. It keeps changing level as we go through the site. We think this is directing the course of these ancient river channels. What we have down here, you can see the bed of an ancient river where bits and fragments of bones have been washed downstream. In this case, very violently, because some of the bones are literally smashed against the rocks. We also found a hand axe here. We found mammoth bones. We found bits of burnt flint, which means we can positively say we had Neanderthals and mammoths living here at the same time, which is really important. On the site, there are a whole series of what we call ancient river channels. So these are the beds of old rivers which have moved and changed over the time. We initially thought there was just one channel. We now think there may be multiple channels as things kept changing. You might have an earthquake which would shift the course of the river, and that's what we're investigating down the bottom. What's very interesting is up at the top here we have quite a lot of flint tools, but they're very poor quality. And I think here people were just picking the stones out of the river, making a quick tool, and then chucking it away again. Further down, we've got flint tools coming out of quite a deep sediment which formed the bottom of the river, and there they might have actually made of much higher quality flint. So we think the Neanderthals there had access to better quality flint and could spend more time making tools. We still haven't found any hand axe down there, but we live in hope. What we also found, particularly at the bottom, is a lot of the bones of large Ice Age animals. We have mammoth, we have bison, we have deer, all jumbled up, mixed up with material, washed out of the Kellaways and what's above the Kellaways, which is the Oxford clay. We're particularly interested in the Kellaways because it's a formation which has hardly been studied. We know the Oxford clay, which is the formation immediately above it, very well because huge numbers of bricks have been made from it. So there are lots of pits everywhere which go in the Oxford clay. They don't go into the Kellaways because if they do, the pits flood. The Kellaways is much sandier. What we've done over here on the other side of the site is we've made a deep pit down into the Kellaways, basically as deep as the digger could get. We've done a detailed section all the way up that side of that face. And now what we're going to do, with all that information, is to start digging down 10 centimetres at a time, and we'll get a very, very detailed account of the Kellaways. And this will be the first time it's ever been done. So this site is a unique opportunity to dig in the Kellaways and get that information. What I have here, we have people on the side, they're looking through the spool that came out of that pit and putting together a representative sample of the invertebrates we can expect to get from there, so that when we're analysing the sediments, we'll have people sitting there identifying the species, and we can actually track already from the initial stratigraphy log, we can track some of the evolutionary changes to some of the organisms as you go up their sediment. We also can look at the pollen analysis, which will give us some idea of how we correlate these beds with those elsewhere. We're looking at microvertebrates, so we're going to take big samples we can put through sieves and find out how that varies from bed to bed. And then also looking at things like grain size and amount of clay and the mineralogical sort of stuff, which will tell us more about the environment and which things were deposited and so on. So because this is such a unique opportunity, we're going to get as much information as we possibly can from the Kellaways, and also have it somewhere in a good repository where it can be available for study. We're really hoping that we'll get a number of MSc theses on this material, because this is an exceptional opportunity. We have to make the most of every bit we can.
So is this just as important as the mammoths?
From my point of view, yes, because I work with Jurassic special marine reptiles, which unfortunately we haven't found yet, but I'm very interested in the Jurassic. It's an important time in the evolution of life. We have completely different types of environments and faunal composition from anything modern today, so that the more we learn about it, the better we understand it. One of the dangers of thinking of deep time, we think that time periods of 1 million years, 2 million years don't matter. But what we have to bear in mind is that if you look back over the last 200,000 years now, there have been a huge number of changes during that time. There's no reason to suppose we didn't have just as much change in a 200,000 year period 180 million years ago, 160 million years ago. The way I put it is, the further back in time we look, the more out of focus it gets. So everything gets blurred, but actually we can look for individual events. I mean, one of my, hypothesis, which people argue with, this Kellaways rock band, which is the underlying, sort of the floor of the core in many places, is packed with ammonites, particularly beautiful ammonites, but also other invertebrates, jumbled in all sorts of different orientations. And one of the findings from last year is that band is particularly high in phosphorus. It's literally 10 times as high as the adjacent beds. So I think that Kellaways rockline, by a single extraordinary event, an extreme flood, a tsunami, something like that, which scooped out a whole load of material, for some reason the biochemical status was such that it became lithified very quickly, and we have this frozen in time, something which perhaps took a couple of weeks. So
that's incredible.
That's right.
Wow.
So I think of we always sort of, I told a story about stellar deposition over time. I think within that we have exceptional events, and it's those exceptional events that give us the beautifully preserved marine reptiles, the dinosaurs, these beds with vast numbers of, sometimes you have a huge bed with just one kind of ammonite in it, stretching over many hundreds of square miles. I think interspersed with the stellar deposition there is occasional extreme events. And if you think about, we talk about once in 100-year storms, once in 500-year storms, what on earth is a once in a million-year storm like?
True.
What is a once in a million-year rainfall like? And we have evidence of this sort of stuff. So I think a lot of what we understand from the fossil record comes from very rare, very extreme events. But generally speaking, if an animal dies, it sinks to the sea floor, falls to the floor of the wood, and within a year you've gone completely. Things eat it. And you have to have exceptional circumstances under which they are not eaten.
What do you think you could find?
I think we'll get a hell of a lot of extremely valuable information. What I hope we find is a plesiosaur.
That's what you're here for?
That's what I'm here for. No, yes, I'm here for. Actually, the other thing is we have some exposures to the Kellaways near Peterborough, but they're very jumbled up from a drainage channel dumped on the side. And from there, we found an exceptional high, rich vertebrate fauna. So hopefully we might hit something like that here, but we live in hope, so it's fingers crossed on that one. We have found some material in the river channels which is derived from the Kellaways. So this morning we found little plesiosaur tooth, which must have come from the Kellaways because it's a taxon we know exists in the Kellaways and not in the Oxford clay. But it's positive. We have found, again, odd bits and pieces of crocodile tooth in the Kellaways and things like that, so we know it's there, but not necessarily here. But what we're hoping to find something here, of course.
Have you found the bottom of it?
No, the digger wouldn't reach that far.
Okay, so if we don't have a bottom to it, do you know how thick it is? Could it be really thick mud and really rare fossils?
It could, yes. We might get down, a metre below where we could reach and find that we're hitting marine reptiles.
That's where they all are.
That's where they were just out of reach. But we basically went down as far as the digger could reach, and as we felt comfortable going down into a pit.
Yeah, of course.
I was a bit nervous until we'd finished doing this section, and we got everybody up again. But it was actually stable. The sides are very stable.
Okay, so let's see how it looks in a couple of weeks.
That's right. Yeah. So hopefully by that time we've dug down to the level of the bottom.